Here's an example. We'd like to evaluate this integral by interpreting it in terms of areas. We want to find the integral from -3 to 5 of f of x dx. If f of x is the piecewise function defined by 2x if x is less than or equal to 0, and by the square root of 25 minus x squared if x is greater than 0. When I'm reading this, it says to interpret in terms of areas. So that means that we're going to want to graph this function and look at the graph. For x less than or equal to 0, my line is y equals 2x. Okay, so y equals 2x. Okay, and then for x greater than 0, my graph is y equals the square root of 25 minus x squared. Squaring both sides, this gives me y squared equals 25 minus x squared. And then if I add x squared to both sides, we have x squared plus y squared equals 25. We know that this is a circle centered at the origin with radius 5. However, we also know, because y is equal to the square root of something, that y is greater than or equal to 0. So that's the top half of this circle. And since we're only drawing it from x greater than 0, we're drawing really a quarter of a circle. Okay. And that circle has radius 5. Now, I want the integral from -3 to 5. We already marked where x value 5 is. Let's say here is x value -3. Then, the net area we're talking about is this triangle and also this quarter circle. Now, if we look at this triangle, this side of the triangle has length 3 because it's from -3 to 0. This side of the triangle has length 6 because the slope is 2x. So this triangle, the area is 1/2 times 3 times 6, which is 9. Okay. Now, thinking about this quarter circle, the area is the 1/4, and the area of a circle is pi r squared, so we have pi times 5 squared, or in other words, 25 pi divided by 4. Now, we interpret a definite integral as a net area. Okay. So the net area, any area that's below the x-axis, like the triangle, counts as a negative, and any area above the x-axis counts as positive. So the 9 counts as negative, so we have -9, and the 25 pi over 4 counts as positive. This is our answer.